We are going to start Unit 3, starting with 2.4 complex numbers. Okay. In complex numbers, we need to keep in mind that we can introduce something a little bit more complicated that you might not be used to. Okay. We've talked about natural numbers, we've talked about rational numbers, we've talked about irrational numbers, we've talked about real numbers. Okay. We also are going to have something called complex numbers. And it's something you may or may not have seen before. Okay. First, let's start by trying to find all the solutions to this equation. If we're doing that, I'm going to go ahead and factor by grouping. So I'll take out my x squared and I'm left with x minus 1. And there's nothing in common on the right. I have x squared plus 1 times x minus 1 equals 0. If I try to solve for this, it looks like I would have a negative root. If I solve for this one, I would get x equals 1. Okay. Now, the left side is what we're going to end up calling a complex number. Okay. All these years we've been telling you you can't have negative roots, you can't have negative roots. Well, actually, you can. The square root of negative 1 is equal to I. Okay. The square root of negative 1 is equal to I. Always remember there are two solutions to a root, so it's really plus minus I. And so that's what actually happens when you have a negative root. Okay. So the square root of negative 1 is equal to I. And we're going to talk about that in detail today. Okay. But I just go ahead and want you to start thinking about that. Now, similar situation here. We can go ahead and solve. I'm going to do a u substitution so that I can deal with squares instead of powers of 4. So I'm going to say u is equal to x squared. Then this becomes u squared equals 1, which I am much more comfortable solving. So now I have u equals the square root of 1, and that's going to be u equals plus or minus 1. And now I can bring back my substitution and I can say, well, u is actually equal to x squared. Okay, so let's go ahead and write that as two separate equations. We have x squared equals 1 and x squared equals negative 1. So we have the square root of 1 is equal to x, and we have the square root of negative 1 is equal to x. So x is going to be plus minus 1 as well as plus minus I. Okay, again, the square root of negative 1 is going to be I. Now, that leads us to the definition of a complex number. Okay, it is any expression a plus bi such that a is a real number and b is a real number and I is the imaginary part. Okay, it is an imaginary number. It's I for imaginary. Okay, it also has its opposite negative I, and they are the only two solutions to what we saw earlier in our first example. Okay, there's a couple other rules with it as well. Similar to any sort of power rule, you have if I squared exists, you have a negative I. So you have I times I, which is I squared, and that will end up equaling negative 1. Okay, that will end up equaling negative 1. I want you to think about it in terms of roots. Okay, I want you to think about it in terms of roots. So the number I squared is going to be the equal to the opposite of 1. And so multiplying I twice is the same thing as turning backwards. Okay. And it's turning backwards 180 degrees. Okay. Or it's turning backwards kind of like going 180 degrees. Okay. I being the square root of negative 1 is turning halfway backwards or going to 90 degrees. All right. Now let's briefly review some square root rule. We might be slightly rusty on those. We don't always use them. Okay. So if we have the square root of negative 1, that is going to be a positive I. And then if we have the square root of a negative square root of a negative 1, that's going to be a negative I. Okay? Works the same way that any other root would work. Okay? Now, if we want to simplify, we can treat the expression very similarly to a positive number. We just want to take out the minus first. So something that you might see is negative 1 times 9, because then you immediately see the negative 1 and you say, oh, okay, I'm going to put that outside as an I. Now you can finish the problem and say, okay, I know that's going to be plus or minus 3, right? The plus or minus coming from the 9. Similar situation, let's go ahead and simplify here. That's going to be 4 minus 16. That's going to be the square root of negative 8. Let's go ahead and split that up to negative 1 and 8. I'll go ahead and bring out that I. And then I know that 8 can simplify to plus or minus 2 root 2. And I'm just going to go ahead and incorporate that I in between. Okay. All right. Looking slightly more complicated, but we can still do that. Okay. Let's see. We have a negative square root. Let's do negative 1 times 16 minus 3 square root negative 1 times 25. Okay. We're going to have a negative I root 16 minus 3 I root 25. Okay. Now, again, theoretically, there are always two solutions to a positive root, but the principal root is always the positive one. And so that's what we're going to work with when we're doing this. Okay. So we're going to say the square root of 16 is 4. So we have negative 4i minus square root of 25 is 5. So negative 15i. And so when simplifying, we will have negative 19i. You are just going to take the principal root being the positive solution. We also need to get comfortable doing a little bit of arithmetic with complex numbers, okay? Because we always want it to be in the form of a plus bi. So let's take a look at this and see what we can accomplish. So we have 2 plus 5i minus 6. I squared is equal to negative 1, so I'll go ahead and simplify that. So we have 2 plus 5i plus 6, or 8 plus 5i. Notice that is in the form that we want, and we can stop there. That is as simplified as we can get. All right, on the next one, we are now just adding. So you're going to combine like terms like you would if it were a variable. So I'll go ahead and rewrite this. I can distribute the plus, which really does not affect the problem at all. My 3 plus 2 is 5. My negative 4i plus 5i is 1i. And so I'm just going to combine like terms and leave it in a plus bi form. Subtraction is going to work really similar. I am going to distribute that minus before I do anything else. And then now I'm just going to subtract 3 minus 2 is 1. Negative 4 minus 5i is going to be negative 9i. And so that is where I get to stop. Multiplication, you're just going to distribute like you would any other type of distribution problem. So we'll have negative 10i plus 35i squared. Always remember to simplify that. So we have negative 10i plus 35 times negative 1. And let's write that correctly in the proper form as negative 35 minus 10i. All right. Here we can FOIL. So just remember foiling, like any other scenario, we are going to have 3 times 2, which is 6, plus 15i minus 8i minus 20i squared. Again, make sure you simplify that. We have 6 plus 7i minus 20 times negative 1, 6 plus 7i plus 20, or 26 plus 7i. Okay. All right. Now, as for our pattern, right, we're foiling like we would any other scenario. So if we say FOIL, our first terms are going to be AC, which are real numbers. The outer is going to be ADI, which is imaginary. And then we're going to have BCI, which is also imaginary. And then we're going to have BDI squared, which will end up being real because this is equal to -1. Okay, so that's going to be your pattern. Just like you would FOIL any sort of quadratic that's in factored form, it's the same general idea. Division can be slightly trickier. We have to multiply um, by the denominator's conjugate. Okay, the conjugate. A conjugate is when you just flip the sign in the denominator. So the conjugate of C plus DI is going to be C minus DI, and we're going to have to multiply that on top and bottom. That eliminates the complexity of the denominator. So 2 minus 5i, 2 minus 5i. Yes, that does mean you are going to have to FOIL the top and the bottom. It does take a little bit of work, so take your time with it. Okay, so we'll have 6 minus 15i minus 8i plus 20i squared. You should always do this math on your own as well because you should not trust that I'm doing it correctly because I'm talking and writing at the same time. So we have 4 minus 25i squared. Now notice I didn't even write the middle portion because it's a difference of squares, so the middle two terms would have canceled out. So I'm going to go ahead and simplify. 6 minus -15 minus 8 is -23i plus 20 times -1 over 4 minus 25 times -1. So I have 6 minus 23i minus 20 all over 20, let's see, 29. And so 6 minus 20 is going to be -14 minus 23i all over 29. Okay. And that is how you're going to handle working with a division of imaginary numbers or complex numbers. Notice that, like I said, the multiplying by that conjugate removes the complexity from the denominator, which is what we saw right here. It ends up just being a real number, which is really what we wanted. Okay. All right, so the purpose of the conjugate is to make the denominator a real number, like I just said. Sometimes it's just enough to multiply it by I over I because that creates I squared. So let's go ahead and do that. I'll go ahead and write it as this over this. Okay. And now we'll just distribute. So we'll have -8i plus I squared all over 4i squared. We'll have -1 minus 8i over -4. Okay. If you want to simplify, because everything is negative, you could also just write 1 plus 8i over 4, because the negatives do cancel everywhere. Okay, either answer would be fine. All right. Now, a quick review on exponents. Remember that anything to the power of 0 is always going to equal 1. The power of 1 will equal itself. And then we can rewrite powers of 3 and 4 as smaller powers as well. Now, if we want to redo this, but with I, it's going to have a very similar relationship. Let's use a different color here. So if we have I to the 0, that's still going to equal 1. If we have I to the 1, that's going to equal I. We'll go ahead and do I squared just for coming full circle. We have realized that's going to be -1. If we have I cubed, we could rewrite that as I squared times I, which we've established as -1 times I, or negative I. And then I'll come up here to do I to the 4th, which we could write as I squared times I squared, which is -1 times -1, which is +1. So some things to note there are that the relationships really do follow all the way through. And so we can then later simplify higher powers in terms of 0, 1, 2, 3, and 4 to make it easier for ourselves. A good example is the one right below. So notice that they rewrote I to the 10 as 8 plus 2, and then they further simplified. So notice that we went ahead and did I squared. We know I squared is -1. I to the 8th is still a bit tricky, and so notice that they decided to go ahead and simplify further as 4 and 2. Okay, we know to the 4th is going to be a +1, and 1 squared is just equal to 1. So here's your 1, here's your -1, which gives you the result of -1. So I to the 10th is just equal to -1. That covers it on the introduction to complex numbers. If you have any questions, please let me know.